The liver is the second most transplanted organ in the body. Each year, an average of 400 Canadians will be on the transplant list. About 100 patients will withdraw from the list because they are no longer suitable or simply die waiting due to the shortage of organs. But is there a way that we could save more lives? Conventional liver transplantation requires organ retrieval, preservation, transportation, and finally, transplantation, ideally within 12 hours. Standard techniques of organ preservation have relied on cold static flush preservation to slow down metabolism and minimize cell damage. However, this is only effective in healthy donor livers. Livers like those retrieved after cardiac death don't fare as well. Transplantation today is limited by a shortage of suitable donor organs. This is not due to the lack of donors, but rather our inability to preserve and repair marginal livers to be suitable for transplantation. At the University of Toronto Selzner Lab, we are investigating a new technique called ex vivo liver perfusion to expand the donor pool by making more marginal livers healthy. The aim of ex vivo liver perfusion, or EVLP, is to create an environment where the liver can function as if it were in the human body. EVLP begins with conventional cold storage for 4 hours. This simulates the time needed to transport the donated organ to the transplant center where the patient is waiting. Meanwhile, the ex vivo circuit is prepared. Our preparation begins with the addition of an albumin-rich Steen solution. Next, washed donor erythrocytes are added to the solution for their oxygen-carrying ability. The solution is collected in a reservoir acting as the body's venous circulatory system. A centrifugal pump functions as the heart, driving the solution to the rest of the circuit via an oxygenator where it receives oxygen. Next, the dialyzer acts as a kidney, keeping physiological electrolytes in balance. The liver is then hooked onto the ex vivo circuit and perfused for 3 hours. This circuit is maintained between 30 and 34 degrees Celsius. Following EVLP, the liver is then transplanted into the recipient and reperfused for 12 hours. Hourly assessments are taken throughout the procedure to assess graft function. This permits us to better predict the liver's viability for transplantation. Using porcine simulated donation after cardiac death, or DCD livers, we examined how livers treated using the EVLP technique functioned compared to those using a common cold storage technique. To assess liver function and injury, we selected 2 well-known biomarkers: Factor V, a blood coagulation marker, and alanine aminotransferase, a liver enzyme. Levels of the molecules in cold static flush preservation and in EVLP were comparable, suggesting that EVLP organs were functionally similar to non-EVLP organs. One of the liver's most important functions is to produce bile. Bile duct injury is currently the key limitation in DCD transplantation. Damage to the bile duct structures within the liver will result in the loss of the graft, retransplantation, or death. DCD liver grafts preserved for either 4 or 12 hours of cold storage with no EVLP suffered a complete bile duct necrosis following reperfusion in the body. In stark contrast, EVLP preserved DCD grafts prevented bile duct necrosis at the end of 12 hours of reperfusion. To summarize, our findings show that EVLP not only allows for prolonged organ storage with normal liver metabolism, but prevents the development of bile duct injury in EVLP-preserved organs, an important improvement over other cold storage techniques. Our research is just the beginning of a brighter future in liver transplantation. EVLP is a promising new technique for the storage and evaluation of organ quality. By combining this technique with more sophisticated molecular diagnostic techniques, we are on the verge of offering better treatment, repair, and regeneration of marginal livers. This strategy will not only increase the number of suitable donor organs, but also improve the safety of short-term and long-term outcomes of liver transplantation.